Morning. Today in this video we will discuss regarding the basic welding technology. The entire welding technology and its process we will discuss into the several parts. In part A, we will discuss the basic metallurgical requirement to perform a welding. First of all, what is welding? The definition of welding is the operation in which two or more parts are united by means of heat, pressure, or both. That means simply welding is nothing, it's a process of joining two members by the applications of heat or by the applications of pressure and produced a uniform bonding between the two material, two part. The two part may be it's the similar kind of material may be ferrous or non-ferrous in nature, and along with that, it may be the dissimilar kind of material. That means fundamentally, welding is a process where we are joining the two metal by the application of heat or the pressure, and in some cases, we are using both as a simultaneous manner. Typically, welding is carried out by some approved operator, which are known as the welder, and this training purpose is to train the welding inspector. So, who is welding inspector? Now, the person who is involved for the control of the overall welding process and to ensure that the entire welding has been done according to the approved procedure and all the variables that is required for the welding that need to be controlled by the some manner. So that means the inspector is the person who will have a control over the entire process. So typically a welding inspector performing a lot of duties, and the typical duties of the welding inspector are: welding inspectors are employed to assist with the quality control activities necessary to ensure that the welded items meet the specific requirement. Next, the welding inspector need to have the ability to understand and interpret the various QC procedure and also have a sound knowledge regarding the welding technology. Then after the completions of welding, the welding inspector need to be perform the visual inspection, and finally to identify the different type of defects within the welding process or within after the completions of welding, required NDT need to be performed for the determinations of the surface and volumetric defects. And all this is normally done with the help of a applicable specification or standard. The thing is, when we are working as a welding inspector or we are going to perform a welding, then what we need a requirement? First of all, we have the requirement of some documents. What are the documents required for the performance of the welding? The thing is, what is the applicable standards? What is your quality plans? And what are the inspection checkpoints that need to be performed during the welding? Applicable drawing, perform the welding, and applicable QC procedure. There are a lot of duties of the welding inspector, particularly before starting the welding. The duties of the welding inspectors are categorized like this. What are the type of material need to be welded? So in accordance with the drawing or WPS, identification and pressings of the test certificate of the used material, filler wear, and whatever the consumption it will be done to perform the welding, that need to be checked with respect to the pressable test certificates. Then he need to be checked the WPS. It need have a welder performance specification, that means the approved procedure. Welding equipment, whatever it will be used, that need to be physically verified with respect to the tag and others required certificates. Welding preparation, in according to the WPS, whatever the essential and non-essential variables is there, need to be judged before starting the welding. Welding consumables, that means what type of electrode, filler wire, consumable gases, shielding gases, all these things need to be verified before start the welding. Then the welding inspector need to have a rights to join the fit-ups. That means whatever the joint we have been create out for the welding, that need to be verified before starting the welding as per the WPS is concerned. Weld face, that need to be defective free, contamination and damage free. And if the preheat is recommended as per the WPS, that need to be done before starting the welding. During the welding inspector need to have the check the following things. The things it he should have a side and field welding, then ensure weather condition are suitable to comply the code. That means if is moisture is there, wind pressure is so high, and according to that, the necessary precaution need to be taken during the welding process. According to the WPS, what is the correct welding process that is properly utilizing during the process of welding or not, that need to be checked and verified. If the preheat is required, then the preheating need to be done. Interface temperature need to be maintained. Whatever the WPS is suggested, what are the welding consumable the welder is using, that need to be checked. Welding parameters, root run, that need to be visually verified, and it will be acceptable as per the concern of the WPS is there. If any kind of grinding or gauging requirement is there during the good workmanship standards during the process of welding, that need to be checked and verified. Internal cleaning need to be done to remove the slags and others. And the welder, approved and registered and qualified welder, whether they are performing their duties or not, that need to be verified by the welding inspector during the course of welding. And after the completions of welding, welding inspector need to be ensure regarding the weld identification, weld appearances, whatever the dimension as required as per the drawing, that need to be ensured. If that drawing is there, whatever the welding has been done, that has been done according to the drawings or not, that need to be checked. If the NDT is required, the required NDT need to be performed. After the NDT, if the repair is there, then it will be monitored the repair, and whatever the repair is required, that need to be done, and after that the required NDT need to be done. PWHT, post-weld heat treatment, if is required as per the material or thickness is concerned, that need to be verified and ensure that it will be done correctly. And after the PWHT, if the pressure or load testing is required according to the drawing or requirement, then it need to be tested and verified. After the completions of all this, whatever the documents you have been used, like the approved WPS, consumables, ITPs, and everything, that need to be documented correctly. So these are the duties of the welding inspector during the course of welding. The thing is, when we are talking about welding, so first of all, what we need to know, what is your joint configuration is there. So basically the joint configuration into the section of welding, it may be simply it's a butt weld, it can be the T type of joint, it may be the corner type of joint, edge joint, cruciform joints, or whatever, or lap joint, whatever it is. So what is the joint configuration that is required according to the drawing, that need to be ensured. These are the type of welds that we are doing into the groove weld. That is the, it may be the butt weld, it can be the full penetration weld, it can be the fillet weld, it may be the slot weld, partial penetration weld, or the plug weld. So whatever the drawing is there, according to that, we need to be ensured. When we are about the groove weld, it has need to be a uniform profile according to the WPS is concerned. We know that there are a lot of zone is there into the weld. The thing is, there will be the root run, then the hot burst, fill up, and final, and the fusion line will be there where the metal need to be melt correctly and with the parent metals. And after the depositions of the welding, certain areas where the heat will produce some changes into their microstructure, which are known as the has area, a heat affected zone, and that need to be ensured what are the amount of heat affected zone after the welding. In case of fillet weld, the same thing is also there. That means according to the configurations of the fillet weld, there are some root areas, weld metal is deposited, and entire width of the weld that is known as the weld 2. Excessive weld metals and fusion line that need to be marked correctly. And according to that, there will be also some heat affected zone is there. First of all, when we are going to perform in welding, what is my requirement? The first thing of the requirement as a building inspector is we need to be make the essentially what type of material need to be welded or what are the type of material need to be inspected. So as the inspector, he should consider the following points before starting the welding. What are the type of material and what is its weldability, material traceabilities, and material conditions and dimensions. All things need to be verified before starting the welding. The thing is, when we are going to perform the welding with a specific kind of material, we know that the material is containing lot of chemically different type of compositions, and the different type of element need to be added into the formations of alloy. So before starting the welding or as a welding inspector, we need to be know what are the type of element we are using for the alloying purposes of the steel and what are their properties. So basically carbon and iron, these are the two main things by which the alloy is in generally generated. Basically, carbon we are using as a formation of strength. Magnesium, manganese, it is using in the form of the for the purpose for the properties of the material to increase of the toughness. Aluminium, it's working as a grain refiner, deoxidizer, and also the toughness will be changes according to the percentage of aluminium. Moly up to 1%, it is controlling the creep resistance. Chromium, it's a corrosion resistant. Silicon, it is a deoxidizer. Vanadium, it's normally using for the stringent of the material. Nickel, it's a low temperature applications. Copper, used for the weathering steel, which is known as basically the cotton steel. Sulfur, it's a residual element which can cause the hot shortness. Phosphorus, it's a residual element. And titanium, it's a refinement element for the alloying system. In generally, any material has a specific weldability. Weldability means how easily the material can be welded. And the weldability of a particular material or particular grade of material or particular type of alloying material is depends upon its carbon equivalency value, which is generally denoted as a CE. So according to the carbon equivalency calculation, it can be calculated by using the formula percentage of carbon plus percentage of manganese by 6 plus cumulative percentage of the chromium, moly, and vanadium by 5 plus cumulative percentage of nickel plus copper by 15. Whatever the value it will become, it will be considered as a carbon equivalency values. So according to the carbon equivalency value, it is determined what is the weldability of your inspection material, your weldable material. Lesser the C values, carbon equivalence values is most important. When the value of the carbon equivalence is very, very less, then we can say it's a weldable material. That means the welding can be carried out in a very controlled manner. So carbon equivalent is important welding because it helps predict the behavior of the steel during the welding, especially in terms of hardening and the risks of cracking. It aids in selecting suitable welding procedures and avoiding the potential issues like that of hardenability, risks of cracking, selection of welding technology, pre-weld preparation, and material selection. Basically, into the industry is concerned, there are different type of welding process is there. Most commonly in our discussion, we will be discussed regarding the arc welding process. And this arc welding process is a part of fusion welding. And there are different type of arc welding processes there, like SMAW, shielded metal arc welding, GMAW, gas metal arc welding, uh, pulsed arc welding, short circuit arc welding, gas tungsten arc welding, flux cored arc welding, and submerged arc welding. So basically the industrial requirement is very popular with the five welding process, and elaborately we will try to learn all the parameters and associated controlling of the equipments and process for SMAW, GTAW, GMAW, FCAW and SAW in our subsequent classes. So welding process, if we are making a model for the welding of a particular component, particular material, then the information for the service conditions, that is the field, we need to be gathered before the welding. That's the weld design, process selection, developing the welding procedure, that is WPS, welding operation, and finally the testing. So in general, the common arc welding process that's known as the SMAW, yeah, sealed metal arc welding, that is MMA, TIG welding process, MIG and MAG, that is the GMAW welding process, SAW and FCAW. So in arc welding process, an arc is created when the electrical discharge occur across the gap between the electrode and the parent metal, and the discharge causes spark to form, the causing of the surrounding gas to be ionized, and when the ionized gas unable to a current to flow across the gap between the electrode and base metal, thereby creating an arc, and this arc generated the heat for the fusion of the base metal. With the exception of the TIG welding, the heat generated by the arc also caused by the electrode surface for the melting, and the droplets can transfer to the weld pool to form a deposition into the weld run. Heat input to the fusion zone depends on the current and the traveling speed of the process. In generally, we can done the welding according to the geometry and is for different position. Basically, the according to the position, it is not known as the 1G, 2G, 3G, 5G, 6G, according to that. So welding into the flat position, yeah, 1G position results in the highest and weld metal deposition rate. And for the consumption of electrode welding process, the rate of transfer of the molten metal to the weld pool is directly related to the welding current density, that is known as the ratio of the current to the diameter. For the TIG welding process, higher the current, the more energy need to be there for the fusion of the filler metal. So in generally, when we are talking about the arc welding process, the most importantly, we need the correct amount of arc energy such that the heat will be produced into the enough amount and the melting of your part will be done correctly, and the deposition of the metal will be done in a proper way. So arc energy in an arc welding process, which is in generally measured by kJ per mm, it depends upon the voltage, amperage, and the trouble speed. And simply arc energy we can calculate it by using the formula volt into amperage divided by trouble speed into 1000. And whatever the arc energy is there, if we are multiplied the arc energy with the thermal efficiency of a particular welding process, then the required amount of heat inputs will be calculated. Thermal efficiency are different for the different type of welding process. Mostly the maximum thermal efficiency factor is there for SAW welding process, which is considering 1. And other than that, SMAW has a zero point 0.8, MEG and MAG, that means GMAW has a zero point 0.8, FCAW is a zero point 0.8, and TIG and plasma is the lowest thermal efficiency with 0.6. So whatever the thermal efficiency, that will be directly multiplied with the arc energy, and correspondingly it will give you the whatever the heat input will be there. For example, suppose a weld is made using the MAG welding process, and the welding parameters are like this. The volt is 24 volt, ampere is 240 ampere, and travel speed is 300 mm per minute. Then the arc energy will be 0.96 kJ per mm. If it is for the SAW MAG welding process, then definitely the thermal efficiency is zero point 0.8. For multiplied with that one, then typically the heat input can be calculated. So heat input is most important. Yeah, when we are considering the welding process, definitely, well, some of the parameters which control the weldings are need to be known to the welding inspector. There are the arc voltage, welding current, and polarity. In generally, arc voltage is related to the arc length. Welding current has a major influence on the depth of fusion or penetration into the base material and to the adjacent weld run. And the polarity determines whether most of the arc energy or heat is concentrated at the electrode surface or at the surface of your parent material. So the input of heat and which locations will be there, that will be considered according to the polarity. So in generally, the polarities are considered according to the weld process. For particularly SMAW welding process, direct current electrode positive, that is the best penetrability is. Direct current electrode negative is less penetration but higher deposition rate, used for the root purposes and weld. And for the AC welding, in case of SMAW, not suitable for some electrode, minimize the arc blow. In case of TIG welding process, rarely used. Direct current electrode positive is normally used. We do not use it because the tungstens will be overheated, and there is a possibility of melting of tungsten electrode, and the tungsten inclusion will be a welding defect will be there. So in generally, in case of TIG welding process, we are used for the all metal except the aluminum, magnesium, and magnesium alloy. Yeah, after by the for the case of aluminum and magnesium, due to the refractory issues, the direct current electrode negative is in general not used. But for the others metal, like that of the TIG welding process of the steel and alloying element, direct current electrode negative is in generally preferred. AC welding process in generally recommended for the aluminum and aluminum alloy to break up the refractory oxides. In case of GMAW solid wire welding process like MIG and MAC, generally direct current electrode positive used for the all metals and vertically all suitable. Directed electrode negative is rarely not used, and AC is also not used. In case of FCW welding process, most common is the direct current electrode positive, and in some position, basic flux wire are designed to run. In that scenario, direct current electrode negative in generally using. SAW welding process, we have requirement of the deeper penetration, and in that scenario, direct current electrode positive is generally recommended. When the less penetration has a requirement but higher deposition rate is concerned, then direct current electrode negative in generally we are using for the SAW welding process. In welding process, there are two type of power source. In generally, we are using constant current power source and constant voltage power source. Constant power source, that means the constant current power source. In this scenario, this is preferred type of power welding sources for the manual welding of MMA and manual TIG. So whatever the manual process is there, like that of SMAW and GTAW, yeah, TIG welding process, we are preferring to use the constant current type power source. and where the automation or semi-automation is there in the case of welding, like that of SAW, MAG, MIG, and FCAW, where automation has to be done. In that scenario, constant voltage power source we can use. So this is the preferred type of power source for the welding process that have a wire feeder, and that are the MIG, MAG, FCAW, and SAW. So in generally, there are the characterizations of the power sources, current effect, the meltdown rate of the consumption rate of the electrode, and voltage control the length of the welding arc and resulting the width and volume of the arc cone. So these are the general parameters which have to bear knowledge of the welding inspector before starting the welding. So these are the basic fundamentals of the welding process, and we have just learned today. In our next classes, we will detailedly discuss regarding the our first arc welding process, that is your SMW welding. Thank you everyone for participation and listening. Thanks.